If you clicked on this video, it's probably because you're preparing for the November digital SAT. Make sure to stick around because we're going to be reviewing some problems. Also hit that subscribe and like for further videos related to more types of problems that you potentially could see. Note disclaimer below and let's get started. Okay, so you're going to be seeing more problems on the digital SAT that review concepts that are in statistics. So usually when you go into Desmos, you can see the function mean, median, min, max, quartile, quantile in terms of if you click Desmos and you were to look at it. However, for the new digital SAT, you'll see in this problem that they say four clubs each recorded how many hours their members volunteered last month. Each table shows the number of hours and the number of members that volunteered. So they gave you frequency and hours for each of the four clubs, and they ask you to deduce what the median is. The problem with this is with the median, that's the middle number, you need to do some work prior before you can figure out the median itself, which means that you're not going to be able to utilize Desmos itself to its fullest capacity with those statistics-based functions. Instead, you can plug and chug values. So what do I mean by that? Let's take a look at Club A. So first we need to figure out median means the halfway point, and you are still going to need to know that that's the halfway point, right? Because for the new digital SAT, even though you have those function bubbles, you can use it to sort of test yourself out. If you're not sure what median is, you could type in random numbers and be like, oh, does median mean the middle number? And it'll give you the middle number. But to be more efficient, you should just know median means halfway in between. And because we're taking a look at the hours and as the median number, what happens is we're going to need to know what the hours in between is based on the frequency. So you can plug in the sum into Desmos with this frequency. So 4, 5, 3, and 2. So 4 plus 5 plus 3 plus 2, or you could plug that into your digital calculator, and then you would go ahead and get 14. You would do the same thing for Club B, and then you would get 14. Club C, you would take the sum of that, and you would get 12. And Club D, you would get 10. So they're looking for the median in between. What is the median value in between? What are we looking in terms of the frequency, the number of people that were chosen? So halfway between 14 is somewhere between 7 and 8 because it's an even number. So you would have between 7 and 8 between these two. And then 12 would be somewhere between 6 and 7-ish. And then 10 would be somewhere around 5 and 6 because these are even numbers. So you're going to take the two middle numbers and divide it by 2 technically. Or you could take a look at the middle in between. And if you were to look at 7 and 8 and count the hours, right, for the median, you would look at the hours in between those people. So what I mean by that is you have the first four people here, and then 5, 6, 7 would be in the frequency this way. So this would be around 3. So the median would be 3. Same thing, you're looking between 7 and 8. You could start at the bottom or at the top. So if you were to look at the top, let's switch it up. So 4, 5, 6, then it would be somewhere around here. So we're looking between 4 and 5 because it's somewhere in between these two. So I'm going to do 4, 5, Club C. Same thing again. If I'm estimating, I'm between 6 and 7. So I'm somewhere between 4 and 5 around these two. Now you can take 4 and 5 and divide it by 2 and get 4.5, but because of timing purposes, I'm just rounding because I'm just looking at the largest. So if I go ahead and take Club D, the value in between is somewhere around 5, 6. So 4, 2 plus 2 of 4, it's going to be around 8. Even if I go backwards, it's a flat out 8. So I don't need to really calculate these two, noting that my final answer is D. So in this case scenario, you're looking at a problem where you're trying to utilize frequency and compare it to the total number. And note that the frequency is the amount that of the individuals that counted those hours, taking that and dividing it by the middle to get the actual amount. So to review, they could give you tables or charts where they take a look at the frequency versus some sort of item, and you can get mean, median, mode where you cannot really utilize Desmos. You're going to have to manually count it out and then use Desmos for the algebraic or the arithmetic part, but you won't be able to utilize it for the statistics portion. And that's because they're trying to teach you or test you on mean, median, mode. And you're going to notice that for the new digital SATs coming up, where they're testing your concept rather than your understanding of the utilization of Desmos. So, yes, I can go into Desmos and plug in mean, median, mode, but that's not really testing my understanding of what is median halfway in between. What is mode most often? What is the mean average? So to do that, I'm going to give you some sort of table, graph, etc., and ask you to deduce what the middle point is. Let's try to tackle this problem together. They tell you to compare two values in exponent form. So if you were to convert this from the radical into the exponent, and we were to go ahead and see which ones would value the best, I would say that A is the same thing as 5 over 4. And then if you take a look at B, it's 4 over 5. By that, what I really mean is that it's x to the exponent of 5 over 4, and this is x to the value of 4 over 5. I want you to keep that in mind when we're reviewing this problem. So basically, I took what's inside the radical, and you have to put that up top. So in A, it's going to be 5, in B, it's going to be 4, and divided by whatever's outside the radical. So that's 5 for B and 4 for A. Keep that in mind because they're saying which one of these values is correct. So you're going to plug that into Desmos. So if I go ahead and plug in 1, you'll see that they're exactly the same. 1 to any exponent is going to go ahead and give you 1. So you could see 1 and 1. And you might be thinking, okay, I solved the problem. I can go ahead and say my answer. Oh, but if I plug in 2, you will see that 5 over 4 is going to be greater than 1, the first one. So I want you to note that here. So when we take a look, 5 over 4 versus 4 over 5, you could see it's 1.7 versus 2.3. So technically, when we plug into Desmos and it is greater than 0, we have to keep going to get the right answer. Going back to our problem, and remember, in this problem, I went ahead and set up the table, A versus B. And for A, it was 5 over 4. And for B, it was 4 over 5. So when we did it and plugged it into Desmos, we found that A, which was 2.37, and B, we went ahead and plugged in our value of X, which was 2, we found out that that was 1.74, give or take. And so 2.37 is greater than 1.74, so the best answer choice is A. Don't get set up by the trap where you think that A is actually 4 over 5 because you think you go from smallest to biggest. That's the first trap. Second trap is don't fall for answer choice B. It says which of the one correctly compares. And because we're comparing A to B, B, it only works for the value of 1, so that doesn't work. So we eliminated those. Why D is not a good answer choice is because we're comparing the values of X here, and you will notice that I'm trying to eliminate the thought process of utilizing X because X is inconclusive. Because if you have 1, if you have 2, it doesn't matter. It's the value of the exponent that's the most important, and we're technically comparing A to B, not the values of X. So because of this, A is the best answer choice for this problem. Let's try the following problem together. So this says a value increases by 6,000%. What is the scale factor of the new value compared to the original? So you might want to think about it in terms of 6,000 bigger means that you're going ahead and you're saying that it's 1 plus whatever the decimal is of this. So if I go ahead and say this is over 100, because it's the same thing as 2 decimal places to the left, I'm going ahead and saying that it's 1 plus 60, which is the same thing as saying 61. So this is just an interpretation of how you view this. So they say the original value is increased by 6,000%. And usually when we think of 6,000%, we think to ourselves, how can it be? The total always has to be 100. So you're starting off with 100% technically, and then you're adding to it the decimal value or 60. So technically, if you take 2 decimal places to the left and then 2 decimal places to the left, which we got 60, so I should have said 6,000, 2 decimal places to the left, that's just 61 again, and that's just answer choice C as the best one for that one.
Appreciate you riding along for our cosmic journey. If today's mission brought you the knowledge that slaps, make sure to hit that like button to boost that signal. Subscribe if you're locked in for our next watch. And don't miss the link tree. It's got all the goods for AP Bio, PSAT Math, and SAT Math. Before I sign out, make sure you're all in one orbit and diving in. Killing out. Till next time.